Millions of people watched the roaring engines and thundering rush of fire and twin pillars of smoke that make up the unique signature of a space shuttle launch. They saw four large machines work together precisely to send astronauts, satellites, observatories, and space station segments into orbit. The four elements, when combined ahead of launch, were called a shuttle stack. They included the shuttle itself, also known as the orbiter, plus a pair of solid rocket boosters and a single external fuel tank. The external tank, or ET, is the familiar orange structure that dominates most images of the shuttle at liftoff. At more than 15 stories tall, it is the largest single part of the shuttle stack. It gets its signature orange color from the foam insulation sprayed on the tank's aluminum structure. The insulation helps the tank act as a thermos bottle to keep the super cold propellants from evaporating too quickly. It also helps prevent ice from forming on the tank's exterior and promotes the right aerodynamic shape for launching into space. The main job of the tank is to hold about 535,000 gallons of supercold liquid hydrogen and liquid oxygen. The lower portion of the tank holds the liquid hydrogen, which is the fuel for the engines. The second coldest known chemical, it is stored in the tank at minus 423 degrees Fahrenheit. The upper part of the tank holds liquid oxygen, chilled to minus 297 degrees. During the Space Shuttle fleet's 30 years of operation, the tank, like the shuttle itself, has undergone numerous upgrades and weight-saving improvements. For example, designers quickly saved 600 pounds by not painting the tank white after the first two missions. Following a few revisions to designs and materials, the latest version of the tank, known as the super lightweight tank, is 17,000 pounds lighter than the first one Columbia used in 1981. The tank also received extra attention after 2003's Columbia accident, which was blamed in part on a piece of the insulating foam on the tank breaking off, striking the left wing, and creating a hole in the shuttle's heat shield. Engineers implemented changes to the foam and the way it is applied and refined before the next launch. Some foam was removed altogether to eliminate risk further. The twin solid rocket boosters, or SRBs, are bolted to either side of the tank, with the shuttle itself riding piggyback. This approach was revolutionary in rocket design when it debuted in 1981. Until then, rockets were built by stacking one stage on the top of another, and then casting off the stages one at a time until a small spacecraft was left on its own in orbit. Until the Space Shuttle's first mission in 1981, no astronaut had ridden into orbit on the strength of solid-fueled rockets. The SRBs hold their own fuel, a mixture of powdered aluminum and a chemical called ammonium perchlorate. When dry, the combination feels like a pencil eraser. The fuel is the solid in the solid rocket booster's name. The 15-story tall boosters work much simpler than liquid-fueled rockets that require complex engines and pumps. They produce nearly 7 million pounds of thrust. The solid rocket boosters do not ignite until the shuttle's main engines are up and running. At liftoff, flames shoot down through the inside of the booster to ignite the fuel. Once ignited, the boosters cannot be turned off. A pair of boosters combines to burn 9 tons of fuel every second. The boosters accelerate the 4.5 million pound shuttle stack to 3,000 miles per hour and 24 miles high in just 2 minutes. By then, most of the fuel is used up and the boosters fall away, leaving the shuttle's own main engines to reach orbit. The boosters parachute safely into the ocean, where they are recovered and reused on later launches. After the shuttle engines shut down and the orbiter is on its way, the external tank falls away and safely burns up in the atmosphere over the ocean. NASA's shuttle fleet performed unprecedented work in orbit during its career, whether deploying spacecraft to distant worlds, setting up the Hubble Space Telescope to view the edge of the universe, or building the largest orbiting laboratory in history. Getting into space to perform that historic work took teamwork with the machinery of a shuttle stack.
The landmark Vehicle Assembly Building at NASA's Kennedy Space Center in Florida is getting a renovation so it can remain a fixture of America's space program. After almost 5 decades stacking and processing Saturn V's and the Space Shuttle fleet, The VAB needs improvement on a grand scale to service new launchers expected to debut in the next few years. The new designs include the Space Launch System, a massive rocket intended to return astronauts to deep space. The building also will be set up to host commercial rockets that are much smaller. With that in mind, engineers from the Ground Systems Development and Operations Program have designed flexible systems that can meet the needs of several different kinds of boosters. They also are making provisions for handling spacecraft, including NASA's Orion, now in development. But much of the work will focus on replacing wiring, cables, and fire protection system piping to meet modern standards and increase reliability. Already, 70,000 feet of cabling have been pulled out of the building's cable trays. In all, 50 miles of cables will be removed. Most are bundles of copper wiring that were common in 1965 when the VAB was constructed. Now, it only requires a couple of fiber optic lines about as wide as a finger to meet the needs of rocket processors. 7 huge platforms bolted in High Bay 3 to service the Saturn V will be removed to make room for modern structures, each weighing about 90,000 pounds. The new platforms will be outfitted with everything required to process a rocket and spacecraft. The focus is to upgrade the VAB for a new generation of launchers and missions to allow NASA and its partners to continue to meet national goals of space exploration.
T-minus 10, 9, 8, 7, 6, 5. All 3 engines up and burning. 2, 1. 0 and liftoff, the final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
Program, Houston. Roger, roll, Atlantis.
Houston now controlling the flight of Atlantis. The space shuttle spreads its wings one final time for the start of a sentimental journey into history. Main gear touchdown.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
We copy your will stop, and we'll take this opportunity to congratulate you, Atlantis, as well as the thousands of passionate individuals across this great spacefaring nation who truly empowered this incredible spacecraft, which for 3 decades has inspired millions around the globe.
A year after the retirement of NASA's space shuttles and their shipment to museums across the nation, the workforce at NASA's Kennedy Space Center in Florida is remaking America's gateway to space. A dynamic infrastructure is taking shape, one designed to host many kinds of rockets and spacecraft, sending people on humanity's great adventures. Orbiter Processing Facility 3, no longer needed to service shuttles, has been revamped and turned over to Space Florida. They will partner with the Boeing Company to manufacture, assemble, and test the company's Crew Space Transportation CST-100 spacecraft. OPFs 1 and 2 also are expected to be used in the future for spacecraft processing, as Kennedy's unique capabilities are adapted to new users. Negotiations are also underway at Launch Complex 39 for the use of its twin pads, A and B.
We still have many challenges in front of us, but I believe our future is bright. And as great as our last 50 years have been, I believe our next 50 years are going to be even better.
Some of the work has already paid off, offering the NASA community hints of what the future holds. SpaceX, for instance, launched a demonstration cargo delivery flight to the International Space Station in May. The company and NASA proved that cooperation can overcome daunting technical hurdles safely and effectively. Like OPF-3, the high bay at the Operations and Checkout Building has been remade into a modern aerospace factory floor. Space Florida and Lockheed Martin Space Systems Company renovated the facility, once used to process space vehicles in the Apollo era. It will serve as the final assembly and checkout facility for the Orion crew exploration vehicles, which includes the crew and service modules. The first space-bound Orion rolled into the facility June 29th to begin assembly and processing for a flight test in 2014. NASA and its astronauts are counting on the Orion to take people into deep space for the first time since Apollo.
We don't know what we don't know. And when we find those things and we make those discoveries, we're going to be better off just as a people, but also it's going to have applications that help make our life better.
Workers and technicians are refurbishing the Vehicle Assembly Building, Launch Pad 39B, and numerous other facilities in anticipation of a new golden age of spaceflight. When the work is completed, the center will, for the first time, be equipped to assemble, process, and launch several kinds of spacecraft and launchers, including ships designed to take astronauts far beyond low Earth orbit. The Commercial Crew Program, based at Kennedy, has made strides toward bringing those vehicles into existence by sharing NASA's hard-earned expertise with private companies. The goal is to develop innovative spacecraft to take astronauts to the International Space Station. While the launchers and spacecraft that will take people into space are invented and tested, NASA's Launch Services Program continues to dispatch NASA explorers of a different kind to survey the cosmos and visit some of the most tantalizing destinations in the solar system. Riding atop an Atlas V rocket, the car-sized rover Curiosity lifted off from Kennedy on November 26, 2011, on an ambitious mission to place a robotic geologist on Mars so researchers can find out more about the mysterious red planet. The Juno mission also began at Kennedy with an Atlas V thundering spaceward on August 5th to place the 4-ton spacecraft on a course for Jupiter, the largest planet in the solar system. A pair of small spacecraft known as Grail were sent to our closest astronomical neighbor, the Moon, on a Delta II rocket on September 10th to map the lunar gravity field with unprecedented precision. From new programs being established to the refurbishment of center landmarks to the successful launches of innovative spacecraft, Kennedy remains at center stage in NASA's space exploration ambitions.
The road to space has always and always will lead right through the great state of Florida.